In this exam question, we're going to use what we know about moments. But before we do, let's start by labeling all the forces acting on the diagram. It tells you there's a non-uniform rod, meaning that the weight does not act on the center. It tells you the length of the rod. It tells you the mass of the rod. It also tells you, but the thing is with that mass, we know for sure it doesn't act at the center because it's non-uniform. So let's leave it for now. We'll label it later. A mass of 10 kg is placed on the rod at C. So that should say rod, not road. So we know for sure there's a mass placed at C, and that mass will have a weight of mg. That's 10 multiplied by g. That's at a distance of 40 centimeters from A, just like it says here. It's held in equilibrium. Okay, that's very important because in equilibrium, that means two things. It means that the resultant force acting at any point is 0 on the object, and it also means that clockwise moments are balanced by anti-clockwise moments, acting on the body. I'm just going to quickly write that out and we'll do the rest of the question. It's held by two inaccessible strings. So whenever there's a string or a rope or a tow bar connected to an object, there's always tension acting up that object. In this case, a tension acting up a string. Now, I've labeled them both T, but they should be like tension at A and tension at B because we don't know for sure that they're equal in value. Oh, and actually, it tells you here that they're not equal in value. It says given the tension at A is 10 greater than the tension at B. So that means that the tension at A is 10 more than the tension at B. So straight off the bat, we can replace the tension at A with tension at B plus 10. And it tells you to find the distance to the nearest centimeter of the rod center of mass from A. So like I mentioned before, we don't know where the rod's mass acts, where the rod's weight acts. Let's call it a distance x, and that's what we're trying to find. Again, I'm not sure that it's here, but it helps to label it on the diagram. Now the weight of the 15 kg mass would be mg, so again 15g. And how we're going to do this is we're going to take clockwise and anti-clockwise moments. Let's take it about position A. About A just means I'm picking A as the pivot. No specific reason, just because we're given this distance, we're trying to find x, and we also know this whole distance here. I think it's the easiest way. Once you've picked that, let's first distinguish between clockwise and anti-clockwise moments. Oops, sorry, let me just get rid of that. Sorry about that. Okay, so if I just change the pen color to red. So if this is our pivot, this force here would create a clockwise moment. This force here would create a clockwise moment. This force would go the opposite way. It would create an anti-clockwise moment. On the force acting on A, well, we know moment is force times distance from the pivot. Because this force here is not at a distance from the pivot, that means the moment will be 0, so we don't need to take it into account. So if we consider the clockwise moments, that's the force of 10g multiplied by the distance of that force from the pivot, which is 40 centimeters. Let's leave it as 40 centimeters because it wants the final answers in centimeters too. Normally I'd say converting to meters, but yeah, we don't really need to in this case. You add on to that the other clockwise moment, which is the force of 15g multiplied by the distance of that from the pivot A, which is x. And you make that equal to the tension at B, which we are unaware of, multiplied by the distance of that from the pivot, which again we're going to leave in centimeters. Forming an equation, we have 400g minus 15gx is equal to 200 times the tension at B. Now we've run into a bit of a problem. We can't find the value of x because we don't know the tension at B. And that's where we use the second fact that we know about objects in equilibrium, the fact that the resultant force is 0. That means that the sum of the downward forces, 10g plus 15g, which is equal to 25g, is balanced by the sum of the upward forces. So tb plus 10 plus tb is 2tb plus 10. And this equation here, because there's only one known of tension at B, it allows us to solve for that tension at B, which we can then use in this equation here. So let's do that. Start by subtracting 10 from both sides. 25g minus 10 equals 2 times the tension at B. Divide both sides by 2 to get that the tension at B is 25g minus 10 all over 2. And I'm just going to very quickly do that on my calculator. So we have 25 times 9.8. Take away 10 all over 2. And that's equal to 117.5 newtons. Now that we've got the tension at B, we can put that into this equation. And yeah, let's do that. 400g minus 15gx is equal to 200 times this value here, 117.5. From there, let's rearrange for x because that's what we want as the final answer. You start by subtracting 400g from both sides, and then you divide both sides by minus 15g. It looks a little bit messy, but yeah, this will get you to the right answer. Remember to replace g with 9.8. So I'm just going to very quickly do that on my calculator. 200 times 117.5, take away 400 times 9.8, all divided by minus 15 times 9.8. That's equal to, oh, be careful about the minuses, 133 centimeters. Okay, that means that the center of mass, where the weight acts for the 15 kg particle, is 133 centimeters away from the pivot at A. So that's your final answer to the question. Pretty difficult question, but just as a rule of thumb, whenever there's an object is in equilibrium, its resultant force is 0 and its clockwise moments are balanced by its anti-clockwise moments. If you enjoyed the video, please leave a like, and I'd appreciate if you subscribe. Thanks for watching. I hope this video helped. If you have any tutoring inquiries, be sure to visit my website, www.excellineducation.co.uk. It's on the first link in the description too.